my favorite conference I've ever been to in my life, because it's real world problems and thinking about things where there's no particular discipline that has, well, we have the answer. It's fantastic. I think it's absolutely fantastic. Yeah, I'd like in my talk to kind of take you on a journey that I've been on in a problem that I'm having trouble dropping. Every time I'm doing it, every physicist I met always said to me, you shouldn't be working on it, you should drop that. You know, that's not a good thing to be working on. I can't drop it. You know, every time I go to drop it, something, you know, kind of interesting, whether you call it interesting or terrible, happens, and I carried on doing it. In fact, but the only reason I'm able to do this, I have to do a big shout out for Maita here, because when I first came out, I was at Oxford, in a faculty member there for many years, came over to Miami, didn't have any kind of grant, and it was Maita, through Maita and Brian, that I got the first grant, and it was precisely to work on, at that time, it was IEDs, and what's going on with IEDs out in Iraq, and you know, how can you model that? I'm not sure I did anything useful on that, but that got me interested in how the heck do you model bad stuff? And I couldn't kind of put this down. And so this is the journey that I went on, and it's kind of, I'll share with you the tiny little successes that we've had in this. So in this talk, there are many people that help me. I interact with, you know, I sit with a political science, somebody from political science. I'm now co-director, I guess, of this new Knight-funded institute at George Washington University in data. I've got to get this right, otherwise I'll get kicked off. It's the Institute for Data, and there's the word democracy and politics in there somewhere as well. And it's all together, but it's Knight-funded. And the idea is, how can you work out what people do with information, misinformation? You already heard some of that from Carol, disinformation. How do people react to that? You know, what's going on with that? Because there's a lot going on with that, and we're in the perfect town to be looking at it. Maybe Washington DC at the moment. You know, I've been in 3 cities that I know very well in my life. Kind of called DC, starting to be that. London, where I was born and raised, which is sort of a crazy place now, as well, because of Brexit. DC, which is definitely a crazy place at the moment, and then Bogota, Colombia, which was originally the craziest and now seems the most kind of sensible of the 3. So anyway, yeah, so let me kind of give just an outline of how I'm going to go. I started off talking about Maita, worrying about the offline world of what is it with insurgency. You know, when you look at, it's got me into awful trouble with political scientists, but when you look at different insurgencies, or you listen to the radio, you know, the news, whatever, oh, 3 killed here, 5 killed here, and then there's a break, and then there's 50 killed, and you know, what's going on? And so I was doing this back in 2002, when I was in Bogota for a year, where there was still the war with the FARC, the guerrilla war. It was the interesting thing. Was it a guerrilla war? Was it a narco-guerrilla war? Was it, you know, were they this? Were they that? You know, in the end, what I was more interested in the numbers. What did the numbers say? Because that was my first error in terms of political science, really, because it's, oh no, you've got to label it like this before you go then, you know, deep dive. In fact, now I'm not going to worry about the labels. I'm just going to worry about the numbers. And the Iraq war was going on as well. So, oh, is that, you know, but that's out in the desert, and it doesn't matter. Let's just look at the numbers and what comes out when we look at the numbers. So I'll take you through that, and then we'll move on to, of course, what then happened. Well, wars went on and insurgencies went on, and then the online world appeared, where unfortunately the online world was used very much by ISIS supporters to develop their whole support system, to get financing, etc. So that kind of played in. So how does that work? And then, you know, that seems to, well, that's now coming back. But then there's the whole stuff with hate and all these one-off attacks and what people get groomed on the internet. Do they, don't they? What's going on there? And now we've got also that mutated world. The internet's also a kind of source of general distrust, And what's happening with that? So I'm not sure I have many of the answers for this, but it certainly means that you know, that's why I can't put this problem down. And probably it feeds into some of these other issues, like the adoption of solar panels, or what people do in terms of what the information is that they get and how they're interacting with everyone else. That's kind of a core problem. I've been lucky enough to have published it in a few journals, and I put a paper in the conference and that online box if anyone wants to see more results. Although I'm going to talk about this nasty, dark stuff, the challenges, I think, are general. Because the challenges are, how do you model something across spatial temporal? I don't have the answers for these, by the way, but I put them up there because these are the challenges that I think we all have. How do you model across spatial, temporal, and now online scales? If online scale even means anything, when I can immediately, connect to somebody in Australia or something like this. And how do I develop a model that integrates data and generative models? We all have generative models in some agent-based model, a network model. They're all generative in some sense. But now there's data, which is great, but data can be a pain in the neck as well. Because the more data you have, the harder it is to have a model that kind of in any sense agrees with it. And, what are you going to do? And I think a great example of this, and I shout out for Matt's book, because it's the same kind of issues for whatever topic. It's water, it's food coming from restaurants, it's tax evasion, it's all to do with kind of what people do collectively. And unfortunately, insurgency, extremism, hate, etc., are not done by people sitting alone in a room who never interact with anybody. So it's the same kind of issues will arise. My background, I'm a physicist, so I'm already biased how I view these problems. I view problems like water boils. So for physicists, normal water is not very interesting. The things they're interested in are how across scales do 10 to the 24, in one of these bottles of water, 10 to the 24 molecules, which, getting up to the size of, it's a lot bigger than the population of the Earth, but on the Earth, but that's a lot of objects. How do they boil? What is boiling? And when you begin to look into it, actually even the stuff I was told in physics isn't really correct, because what happens when you, and the only reason I know this is because I took a picture of one of those fancy kettles, the water heaters that I bought off of Amazon. It had a window in it. And so I actually took a side picture of the bubbles as it was forming. And it's really interesting, because as the thing boils, of course, sat and sort of knew this anyway, but I'd never seen a picture of it in all my years that I paid to study physics. There are big bubbles, there are smaller bubbles, there are tiny bubbles, but there are 10 to the 24 objects there. There were not 10 to the 24 bubbles. A lot of these objects have formed into bubbles. It must be something to do as well. If I remove all the bubbles, by definition, there is no water boiling. So it's nothing to do with this thing called the temperature, which I spent, again, thousands of dollars on physics books trying to learn physics. And I still teach and get paid for it. It's nothing to do with temperature. It's to do with the fact that there are these things called bubbles. And they form by themselves. Just so happens that the way you get that is by putting it to 100 degrees. Except when you're in Santa Fe or wherever, it's a change in temperature. But the whole point of the whole angle of physics on these types of problems that we're interested in this room is that there's some kind of, what helps you in the agent-based modeling, it goes back to, the first talk today about looking for kind of simplified models. There might be some kind of self-similarity. You haven't got to do an agent, you haven't got to do a model for 1,000 objects and then 2,000 and then 20,000 and then 2 billion. There's some, perhaps, kind of self-similarity that helps you. And maybe you need to back that up by some kind of statistical power laws. It turns out when water boils, there is a statistical power law. That's the kind of control. So big bubbles are the same as smaller bubbles, which are the same as tiny bubbles. Not true in social systems, but maybe that gives you a thing to hang on to. And that gives you some idea of scaling then in terms of the properties, and you can renormalize. A bubble on one scale then becomes, you know, you form some collection of objects. That becomes a renormalized object on another scale, which you then form another collection of objects, which becomes a ring, etc. So that's the angle that physicists come from it, and they come at it from it precisely with the idea that they're lucky. They have a pretty much exact scaling rules that occur just in nature near transition points. But then maybe that happens in social systems. Everyone says, well, you know, people are different and all this kind of, yeah, maybe they are, yeah, of course they are. But maybe there's something like it, and that can guide the way we do modeling. Okay, let me show you the real system. So, back in the day when the war was going on in narco, whatever you want to call it, war was going on in Colombia. While I was there, we studied, you know, we were hearing all these things like 3 people killed, nothing, 60 people killed. So we just looked, first of all, at what it would look like in terms of, I took those events and just made a ring, think of the bubbles, a ring the size of the bubble, and then let that decay over time. And what would a war look like? And when you set the war going, it looks like stuff bubbling. It doesn't look exactly like stuff bubbling, and there are different colors. Why are there different colors? There are different colors because in the end, there are different armed groups. And there are civilian groups, and then there's paramilitaries, and then there's, you know, the formal FARC, and then there are splinter groups, and then there's the state, etc., etc. And maybe they themselves out in the jungle don't actually know, you know, if you give them a label, what's their label? It happens set in Northern Ireland as well, you know, IRA, then they're with the real IRA, the more real IRA, you know, in the end, and it sounds, you know, and but it's just people getting together, doing stuff. The interesting thing is when you take all those bubbles and you just freeze them at one moment in time, so like now, or, you know, go back to because it's so now. But I just freeze it at some time, and then I plot out like a histogram of the heights in this room. Histogram of the heights in this room, we know, bell curve, normal distribution. Doesn't really happen in terms of the size of it. Size is, this is the lethality of events. So I'm just going to take events on a certain day, or a certain month, we could even do it. Doesn't really matter, doesn't change things. And I do the number of events that killed a certain number of people. And I plot that out on a histogram, and we look at it, and we do the statistical test. Aaron Clauser, Mark Newman, Cosmo Shalisi came up with this really rigorous, unbiased way of doing parallel testing. It's a non-trivial thing, but I won't get into that. But then, you know, what comes out of that? Well, what you get out of that is something like the slope on the mountains near here. If you were going skiing, and that number 2.5 is just like something like the slope. And there's a goodness of fit. Don't worry about that because it just says that, yeah, it's likely to be a parallel. You can never say something is a parallel or not. It's likely to be a parallel. This is for ISIS attacks, actually. This is for Colombia, but this is ISIS attacks. You get the same thing, a similar thing, no matter what war you look at. And this is the first message after all these years, back from 2003 up to now. All those years, people have been sharing data with us. We've been collecting data. There's now, in Norway, there's this whole repository of data for conflicts. There's now data, there were wars broken down by regions. There's now a whole set of data came out for Africa, for different wars in Africa. And there's not even any boundary between these wars, between the countries. And so we just take what look like well-defined wars. We do this distribution exactly like the heights. These are individual events within the war. Think of it like the height distribution in this room. Every dot there is the number of people with a certain height. But it's actually the number of events that killed that number of people. So we do that across all these wars, all these conflicts. Doesn't matter what they're called. Some of them are called conflicts. Of course, the Brits would call the one in Northern Ireland the Troubles. That's a weird way of saying a war. But they're all wars. They're all violent human interactions collectively. And when you put those all onto one plot. Something interesting happens. So I'm going to take, these are the slopes of the mountains, slopes of those mountains you just saw. They're plotted on the vertical axis. On the horizontal is something that's just like a goodness of fit. If it was really, really low, there'd be really little evidence of a power law. Anything above 10%, it's getting good, and a lot of these are higher. But we take all of those wars. Doesn't matter, they're in Asia, in Africa, it doesn't matter. Doesn't matter. All the existing data that there is on wars, and you plot it out, they all seem to have values that, they're scattered because a lot of this data isn't perfect. They all seem to be around this kind of 2.5 value, which is interesting. They're not 3.5, they're not 1, they're not 30. Of course, when we first did it, we first published it in 2009 in Nature, we had 11. People, of course, turned around, you didn't have that war in Africa. Okay, so there's the data, the analysis. But you never, and then we published that in 2000, I think it was 13, and we had 20 wars, etc., etc. But this is the latest, and everything that we seem to look at scatters around that. We also looked at terrorism, terrorist organizations. Aaron Clausen also did this as he did the whole database. We did it by organizations. Also seems to be around 2.5. So it doesn't matter whether they're freedom fighters, it doesn't matter what they label themselves as. The way in which humans collect, like the traffic, the way in which the traffic falls is probably the same around rush hour, whether you look in Paris, Miami, DC, etc. Of course, the details are different, but the general patterns are the same. Liquids boil by forming bubbles of all sizes. Soup is different from coffee, which is different from everything else. However, the way in which it does it seems to be mechanistically similar. And when we look at things like accidents and diseases, they're just completely off the chart. So they are different because they're just not collective human violence. So the way humans do collective violence seems to have some common patterns. And the kind of clue to why that pattern might be comes from a collaboration with John Horgan, who social scientist at now at UMass, who mapped out the network of bomb-making cells in Northern Ireland. And it looks like clusters. The people in clusters, it's like the household clusters for the adoptions. Some are neighbors, some are not, but there's clusters, and clusters of all sizes, like bubbles of all sizes. So this motivates, and I know there's been a lot of work in the agent-based community about modeling conflict, but this set us on the path then of what's the minimal model, what's the simplest generative model that can reproduce 2.5, not 2.9 or 30, but 2.5. So of course you can construct models with, blue's always the state, red is always the insurgent, the small, whatever you want to call them, and green are always civilians. And you can come up with, of course, it's a 3 population model. You can do all the sorts of, lots of parameters, etc. And we did that. And when we look at those, different wars, this was back in 2009, with all our rinky-dinky lots of parameters, we can get good fits. Not surprising, really, but we can get good fits with that kind of 3-parameter model. But it probably misses the point. It misses the point of what is going on, what's actually going on that makes it this common pattern. And so this got us thinking. I apologize, some equations, not that much coming up in terms of equations to really go through. There's a simple process. When people, so this is the hypothesis, and this seems to be the thing that actually happens. We thought about it. We thought, well, wait a minute, what's an insurgency trying to do? They're actually trying to build themselves up. They're just, it's like, so if there's say a group of 5, I forget what I had, 4 who are coordinated, I just use 4 because I couldn't go through PowerPoint and put more and more sticks on. It could be 450, but 4. If they join with a group with a cluster, we got in so much trouble. We're calling it groups and cell. Oh no, you can't call it a group because that's a formal definition of a social science construct. Okay, I'll call it a cell. You can't call it a cell because that's a word. In the end, we call them clusters. Nobody seemed to object to clusters except the physicist, who then say, you haven't defined what the thermodynamic. No, I'm going to call it a cluster. I'm a physicist, I'm going to call it a cluster. I'd rather fight with the physicist. So we call them clusters. So cluster of 3, 4 combines with a cluster of 3 to give a cluster of 6. That's what they want to do. So what happens if I just take that mechanism? That's a mechanism called aggregation. You just aggregate. So I start with all these individuals. We could do it with Lego here. We could sit here with Lego and we start building up. Right. And every so often, we've got the big good or bad state coming in and breaking them apart. That's all I'm going to put in. I'm going to put the coalescence and the fragmentation. You put those two things in, and you can show pencil and paper, no electricity needed to get this result. Just a big, good sharpener to go on a big pack of paper. You can go through and you can formally show, I mean, like this is pencil and paper mathematics, generating functions, etc., etc., etc. You can formally show that you get the distribution of sizes of these clusters doing this Lego. It follows a power law, and the slope is exactly 5/2. It's not 6/2, it's 5/2, which is 2.5. And that's interesting. Now, I'm not saying, so that's not the same as saying that's conflict. So now I've got to make the assumption that I've got all these kind of half-built blocks of Lego now. I'm going to assume that they randomly get involved with actions in a conflict. So the distribution of cluster sizes will be exactly the same, or proportional to, if you want to say it, not correct mathematical word, but it's the same as the distribution of casualties. Because every time a cluster of 7 acts, it has 7 lots of damage that it does. Just going to have that. If you do that, then you get this result that can, quote unquote, explain that common pattern across all of conflicts. So I'm still in, every day my mailbox is always full of people. So we've just written the book on, civil conflicts. Civil conflicts are really different from cross-border conflicts. Okay, they might be. I'm sure they are. I don't know enough about it. I failed in all the classes I ever took in those kind of things. So I know nothing. But all I know is that the numbers don't suggest that there's a difference. Not in the way in which people then go about it. They wear different T-shirts. But the way they're doing things is the same. There's an assumption in here that you can get down into the nitty-gritty of, in here there's an assumption that looks like a product. So the probability of picking, so in the computer model, if I was doing a computer, probability of picking a cluster of 3 with a cluster of 4 to make a 7 is proportional to the size. But that's just like saying I'm picking a random agent. And of course, the bigger the cluster, the more likely I am to pick that cluster. But it turns out that Barabasi has done some really fascinating work on the communities that form in terms of phone calls and also collaborations on papers that we've all been part of papers. They're probably in his data set. And he looks and he looks at it, and the probability that we interact, or we then form an next paper, it's proportional to the product of the clusters. So there's actually some microscopic, there's some other proxy social suggestion that that's correct. And then bringing up that network before, this was painstaking work of John Hawken going around and asking all these people in the bomb making world in Northern Ireland and in Ireland. That's what you're seeing, kind of big clusters, small clusters, lots of small ones, fewer big ones. It all kind of seems to work out well. And this brings us to, we're not the first ones to look at casualty data. In fact, this Richardson, about 70, 80 years ago, wanted to work this out. And he was looking at casualty data. He didn't have all the data, and he was doing it by hand. But he started this whole process. And it's so interesting that he had a career, because he was doing this. His career was marginalized to a certain degree in Britain. He'd also been an objector to the war. They'd stuck him in the front line without a gun to have to pick up bodies. He was in the French ambulance service. But then his career got marginalized because he was looking at this problem. He wanted to understand if were there patterns going on. And look at this book. I didn't know this book until last night. I found it. Prophet or Professor, because he was trying to work out what happened in human conflict. It's almost like, why do they call it prophet? It's sort of a, that's a slightly derogatory term. Or Professor. I mean, he was an academic. He's now famous. He became famous because of what he worked on turbulence, but not because of this work. But the whole point was he only looked at whole wars like World War II, World War I, etc. That's all that he had the data for. And it's interesting that and I'm not going to go through this technical bit, but it's kind of interesting. We've always had this problem that when you aggregate over all wars, you do the height distribution, but now not for events within a war, the total number of killed in a war. And you do that back to the times of the Greeks, because people did collect numbers for the total war. And you put that on a slide, that's a power law, but it has a slope around 1.5 to 7. The interesting thing is if you aggregate the data from casualties from individual wars, and then you sample, that's giving you an aggregate total for total wars, but you assume that these came from a 2.5 power law, and you aggregate them, and then you sample them. Interestingly, I don't have a proof of this mathematically, we did this numerically, exhaustively. And it seems to give power laws that then peaked around 1.5 to 1.7. So I think Richardson's work, all of Richardson's work is like, that's like the aggregated version of what we've found. Or to be fair to Richardson, all we've done is find the disaggregated version of what he found. Another network picture. But what is this network? This network actually turns out that this is ISIS. This is pro-ISIS support online. So this, having done all that with conflicts, in fact, right now I'm going to move on to look at some unknown effect in physics that people care about. Nobody cares about it. Actually, 4 people care about it in a room, but that's what I need to do for my career. Along come ISIS. 2014, start using the internet for recruiting. This is what they look like on I think it was like January the 15th, 2015. These clusters are now clusters of people online from anywhere across the world who they're not just mentioning the word ISIS, because everyone was mentioning ISIS in that 2015. They were actually actively supporting them, either through money, talking about routes for teenage women to get from Europe down to Syria, etc., etc. We tracked all these. They weren't on Facebook. They got banned from Facebook. This was on Computational, which is a copy of Facebook. It has 100 million people, 500 million people worldwide using it. But at that time, we could track it. We tracked it. And this is what it looks like. So this is the equivalent of water boiling, but it's ISIS water boiling online. I'm not going to go through all the colors. The colors actually mean something. The colors are the ones the bubbles that get banned. So that's a kind of interesting thing. But here's another example. There's stuff going on all scales, just as there are with the bubbles. So if I can get this to actually work. You've got, so this is what it looks like on a daily scale. I'm just taking some tiny little region in here and look, this is the challenge to understand what's going on here. These are ISIS clusters. ISIS supporters online, and you can see bubbles just suddenly appear out of nowhere. They suddenly, on the day, they just form a cluster of, 180 people from out of nowhere. That's going on, and then down at the micro level, what that really is people join. Anyone here a member of a Facebook group or Facebook page? Yeah, a lot of people are. That's what these communities are. So ISIS supporters use these communities as their bubble. And I don't mean bubble in an echo chamber sense. I just mean a bubble. It's just like a space where they could operate and talk to each other. We set about modeling it. As soon as we started modeling it, we realized some people come from UK, some people come from Germany, some people are this position, and everybody said to us, you've got to think about heterogeneity. You've got to think about heterogeneity. You've got to put in models of heterogeneity. And I'm not going to necessarily go through what we did here, but we put in heterogeneity. It turns out that when you add heterogeneity to the model I talked about, the math of it, and then you treat it in a mean field sense, it gives exactly the same 2.5 again. It gives exactly the same 2.5. And then when we looked at I won't go through the details, but when we looked at then the growth of the ISIS bubbles online. This is going through 2015. So these are real people, these are 100,000 people worldwide became core, hardcore ISIS supporters online. Some of these individuals, then, we didn't track individual information, we just looked at open source information. But some of them became, when they were killed on the battlefield, they then became notorious within another bubble. And so we could track that these were actually meaningful people we were seeing. What's interesting is you look at all these bubbles forming, and I'm not going to go through the heterogeneity of it. I'm happy to talk about this if anyone wants to know. But when you look at the size of the bubble, it's sort of a very similar process. The bubbles form. Because yes, just people doing stuff collectively. Well, then they find a group of 178 who also want the same thing. They join in with them. Interestingly, though, when we looked at why people were supporting ISIS in these bubbles, each of the bubbles had a kind of different axis along which some hated the US, some hated the UK, some just hated people of a certain religion, some hated, so they all had a different axis. So when we did our heterogeneity, you said, oh, I need that axis, I need that one, in the end, each of these is like a big bubble forming along a particular axis. There's one interesting consequence of the bubbles, because you could think of how much more time do I have? 20 minutes. Great. There's one interesting consequence of the bubbles, because you might think online and the real world. How do I know that online stuff, yeah, it may have led to a lot of recruitment, etc., but did the bubbles themselves, the growth, when something's boiling, coming to boil, I know, in the end, the whole thing's just going to kind of erupt. Did anything erupt in the real world? And this relates to the talk we had about, kind of picking out protests. When do protests become important based on what's happening online? And what we found is really interesting, and again, details are in the paper, but it wasn't the size of the bubbles that became a good predictor of protest happening in the real world, or ISIS attacking something in the real world. It was the number of bubbles. And in my head, I explain this by, if I'm not, but if I were to become an ISIS supporter, maybe, why don't I just join one big bubble? Why don't I just join the big bubble of ISIS? Because I've got a different nuance on the problem. And this is going to be the same thing true for hate and the neo-Nazi stuff that we found, etc. Everyone's got their own kind of angle on why they hate something. They unify that they hate it, but why they hate it is different. And so what's happening, we think, is that it's not about forming one big bubble. It's about enough bubbles forming along enough different axes, different flavors of bubble, if you like, that in the end the whole thing just goes, because you've got practically every reason for hating is then covered. And what you're seeing here, I'm sorry it's small, but what you're seeing here, this is just an example of how the bubbles appear. These were pro-ISIS bubbles. Ahead of the Kobani attack, Kobani came in the news again recently, but in 2014 it was very much in the news on a particular day in September. They had a huge surprise attack on Kobani, which is on the border between Turkey and Syria, out of nowhere. And the coalition forces knew nothing about it, nobody knew anything about it. And yet, when you look at how the bubbles over time, this is from over a year, longer than a year span, look at this as the creation of the bubble. So when you see a dark line, a bubble has been created and then it exists, and I haven't shown the growth of it. And what you can see is there's an escalation in the number of bubbles that are produced. And it escalates actually, sorry, physics geeky bit here, it follows this inverse law like the transit just before a transition of something in a physical system, an inverse scaling, inverse power scaling. And we found exactly the same thing before the state of Brazil. We were on the back of an IARPA project coming, open source information, trying to predict protests. We failed miserably, and so did everybody on the program. But at a later stage, we realized, yeah, we were looking at Twitter. We were looking at tweets. I passed the White House every day on the way to work. There's always a guy on a box there shouting stuff out. People go around him, they tweet, they photo, they send selfies. With nobody says, I'm going to vote for whatever. It's so convincing. Twitter is not the way that people get convinced. Twitter is the way they shout about it once they've decided something. It's in these communities online, the Facebook group, Facebook page, the Decontacted page and group. That's where the kind of intent and capability is developing. And we see these bubbles develop and escalate before the Brazil winter protests, however you want to call it, protests that were, occurred in 2013, that people are still arguing about the causes of it. Oh, it was the World Cup was coming. Oh no, it was doesn't matter. What we see from the data and from the modeling is bubbles were forming for all sorts of reasons. The important thing was that there were then so many of the bubbles that the whole thing escalated. So we're at the moment, our work at the moment is worrying about the coupling between bubbles online. It's complicated, it's difficult work. We're having to look at different platforms, all the I don't even want to say the platforms because there's all sorts of, so every week, there's 7 social media platforms created last week because it's on GitHub, or how you set up a social media. You can just start up your own social media platform. So there's a kind of proliferation of universes on which what we saw on just one is now happening. So I don't even know how we're going to start modeling that, but we're looking at it now. This is kind of snapshots of the types of things that kind of how the bubbles then begin to merge. We're getting down into the microscopics. On the left, unfortunately, were KKK groups just after the Parkland shooting down in Florida. On the right, even though it's kind of similar, sorry, the color's slightly different, this was the bubbles joining when they heard that there was a possible death of the ISIS leader after a coalition bombing. In the end, it doesn't really matter. There's kind of like similar stuff happening. And it's the stuff that we're trying to understand. There are adaptations of the bubbles. The bubbles, like Darwin, to the power 20, because bubbles can make themselves invisible. You can make your Facebook group invisible for a day or a week. Or you can change the name, and we found that they never called themselves ISIS or something like this. They called themselves, happy, and then they put an extra A in for happy, and then another A. Well, humans can detect it. No social media algorithm can detect that. So there's all these challenges of what we're trying to do currently. Again, I won't get into the details. A paper we published about 2 months ago in Nature has all the details now about focusing on neo-Nazi. That wasn't enough. Now neo-Nazi hate, etc. There's really interesting behavior happening across platforms. In the last few minutes, I want to move to something that is more to do with distrust in general. And I don't want to get this as controversial as it. People don't vaccinate, people do this and don't for all sorts of reasons. I'm not judging that, but I am interested in, there are certain people that think certain health things, even though there may be some evidence against it, they definitely think this. And then there's other people that just go along with what the state thinks, established science thinks. And then there's others that are kind of in between. And I'm probably in between on a whole bunch of things. I don't know. I haven't even thought about them. But there are definitely people out there. So we wanted to find out what that looks like. And it looks like this for the vaccine debate. So I know I'm jumping to another topic, but it's similar. You've got a 3-sided battle. And this is what the battle is about. It's about vaccines. And it isn't just measles vaccines or whatever, it's HPV. It's should I get my kids, should my teenage son get 3 HPV vaccines when there's no history of what that does to you? It's that debate. The reds are the antis. The blues are the pros. That's the Gates Foundation there. I think NIH or somewhere, maybe NSF or somewhere here as well. But then there's all these NGOs and then the greens are the undecideds that are linked within one jump to one of these others. The interesting thing is, if you're the Gates Foundation or you're one of these, you think you're fighting this battle. So this is done with false atlas algorithm. It's not that I've separated out the reds, the greens, and the blues. This is purely done, false atlas 2. it pulls together when there's connections. Think of it like elastic bands or springs between clusters. Each one of these nodes is not a person, it's a cluster of people. It's a Facebook group, a Facebook page. There's actually 100 million people in this graph. You're looking at a graph of 100 million people. Because each one of these clusters can contain up to 1 million. Okay, so it's got 1.5 million in it. And so you're looking at 100 million people worldwide, mostly English speaking, not all English speaking. The blues, and being in Washington is fantastic because there's a ton of NGOs, think tanks that are thinking about this stuff, but none of them have thought about the computational side of it. And when you look at it, if you're a blue, you're pretty happy because that's your war. You're attaching to greens and you see the occasional red around and you think you're winning. If you're red, you're embedded with a ton of greens who in any moment you could flip over to reds. That's how the recruiting occurs. So this map, this network, is actually showing how great, red is almost like an insurgency. Red has, if I total the number of people in red, it's far less than in the blues. And yet, they're embedded with the kind of hearts and minds. It's like the civilian population. They know how to engage with and any one of these, the Greens is the local swim club, the parents association of a school that I might be a member of, anything that any of us, we're probably members of this. Don't worry, there's no personal information. We don't need it. We just count the size of the bubble. So our challenge now, and this brings me to the end of near the end, that's what I'm trying to understand. So I'm trying to understand all the other stuff. But that, when I go back, at least now, if I leave stuff in the seat pocket of the plane, previously when I was leaving stuff, it was ISIS and terrorism. And I remember once absolutely freaking out. I'd left a folder with all this in a plane, American Airlines flight, and you're not allowed back on the flight. And I had to tell them it was my life-saving medicine or something, because the last thing I wanted to pick out of that seat pocket, stuff that was online, they knew I was in that seat. I think I'd be on a no-fly list. So anyway, I got it back. But at least this, I can put it up and nobody knows what the heck is this. But this is that I'm trying to understand, what is it about this network? The reds have grown 500%, some of these, in the last month. 500%. Blues have changed like 2%. So the reds, and somebody said to me, oh, you shouldn't be so hard. I was like, I don't know, maybe I'm a red. I don't know. I think I am. Maybe I am about certain things. But we're now trying to look at it in terms of general distrust, because this is this. Okay, what about diabetes medicines? What about, controversial cancer treatments? It must be something similar to this. So the whole issue of how you understand how the public engage with or solar panels, it must be something like this. Just putting it on the worldwide, on the map. Unfortunately, there are some bubbles that locate themselves. If we zoomed in, we'd find probably some in South. There's a ton around, DC and everywhere where you look, there are. But there's a whole bunch that also think that they're the world opinion, and they're part of this kind of global ether. I can't understand this at all, but we're still trying to do it, and we're trying to work this out. The one result we have is that, and this is almost a no-brainer, if you run this forward a few months, red is going to overtake blue. So by the time the next flu seasons or whatever come out, red's going to have been, there's more red than blue. So that's where we are. That's the stuff we do, the challenges. But the challenges, I think, are very general. How do we do it? We've got the data, we've got the mapping. And so if anyone here in the audience or listening is interested in collaborating on this, we would love to collaborate. Absolutely love to. Thank you very much.
So we do have time for questions. I'll turn questions over to you.
I've got really bad eyesight, so I don't see past to Matt. Would you mind just pointing
out? Well, your hand seemed to go up.
Yeah, seriously, I'm just.
So two things, right? One, the 2.5,
Yes.
2.5 alpha.
Yes.
You have a mechanistic explanation, but of course, generative social science. Yeah. So it's like you have one explanation, doesn't mean
Yes.
a B explanation.
Correct.
Have you tried any other alternatives? That's question one. Question two is you seem to assume that all this is organic, and
Yes.
we know that it's not. We
Yes.
know that there is influence.
Yes.
We know that there is people behind the scenes trying to create this and make it look as it's organic. So
Yes.
have you considered that maybe it's not red and blue and green, it's
Yes.
red and blue and the dark black?
Yes, absolutely right. Yeah, first thing, so since we put this out on Archive in 2005, we've been flooded with alternative explanations. No alternative explanation exists that provides that 2.5 number to date. Someone here can find one, great. But you can find one that gives 2.5, it also gives 2.7, it also gives 30. It's equally good for each of them. Find one that just picks out that 2.5. That's a challenge. The second issue is you're absolutely right. In fact, I work now with David Broniatowski, who did. He's got the now famous paper in Journal of Public Health looking at Twitter bots. And I won't mention the country because I got in trouble last time I mentioned the country. So Twitter bots from a certain country. Yes, you're absolutely right. Interestingly though, they can tend to, it's interesting, they can seed things, but they can't, it's really hard to create something that looks as organic as that. You're absolutely right. Those actors are in there. Working out their influence is going to be another matter, but you're absolutely right. We're on it, but I don't think it's as much as everyone assumes, because a lot of the studies, and this is, so it gets kind of slightly philosophical. A journalistic approach to this is to find the bot and then write about it as though it's the important thing. That's what I find. And it's like they find the story and then they write about it, and you're left with the story but that's a little bit like, remember the camera people who go, there's no skirmish, and they're going to a place and they find the two people who are fighting in a room and they go and take a camera shot of it. It may give a little bit of a biased view. I think it is biased view in terms of the influence. I think there is influence there, but not 100 million people influence. Yeah.
So I was trying to get my head around something. A lot of your talk was focusing on the bad stuff.
Yes.
You said that at the beginning. What I was kind of wondering is, could this generalize even more? I mean, does it apply to good stuff too?
That's a fantastic question. I started off this work in like 2000, trying to work on the immune system. I thought that would be a career move. I work on the immune system. It turns out it's really hard. And this was the closest I got. But I think there's a lot of interesting lessons to learn about how does something like an immune system, you've got a virus coming in, you've got the local, my immune system that thinks it's doing a good job, but it's actually doing a really lousy job. And then I've got the stuff in the rest of my body that's kind of being drawn in. I think this insight into the three-sided game, three-player game, I do think I love to think when I wake up that there's good that can come out of this, yes.
In the back, you can concentrate on the front so far.
I have a question about the microscopic aspects of what I think of as collective construction. So, taking the Women's March, for example.
Yes.
At some point, the group splits off and creates separate focus groups. But they're not able to agree on a common remedy. This is the point where you say, with enough heterogeneity, they come together and there's a phase transition. But in the Women's March, they don't come together. That's why they split off in the first place.
Correct.
And now there are 4 Women's Marches instead of 1
Correct.
Women's March. And I want to know more about the microscopic moment when they, at least in theory.
So do I. We should collaborate on that, and we should get data, and we should look at that, because you're absolutely right. And that's why I'm struggling with this now. There's something about, these are many, many axes here, and there's something forming on one and another, and then does it get worse? I don't know. I'm stuck there at the moment. I mean, I'm working on that at the moment.
Sociologists find out.
Yeah, that can work. I do work with sociologists, but friendly ones. They're really nice. And but yeah, you're absolutely right. In the end, it's got to be a mix of everything. No discipline holds the answer to this stuff. The problems are real. There's no discipline that owns it. And if there's one thing I've learned in all these years, every discipline, including physics, tries to say, that's ours. Imagine a sociologist going and try and write a paper about why water boils. Physicists would go, even if they were right, the physicists would go, you have no idea, you haven't studied this, you haven't looked at what Einstein wrote. Einstein didn't write anything about water boiling, but they'll still say that to you. So you're absolutely right.
Yeah. So I've been ducking in and out of this subject for a long time now.
Oh, right, great.
I wrote about power laws in the Guatemalan Civil War in 2002.
Oh, right, okay,
so,
great, yes. I think we've got that in our notes.
So I have a mechanism I've looked at that I think is maybe a special case of your mechanism.
Oh, good.
Whether you think it sounds like a special case.
Yeah.
If you take a hierarchical tree,
yes,
with branching, the branching can be quite irregular,
right,
at each level, and you look at these spans of control within that tree,
right,
you get a power law.
Yes.
And if you assume that basically everybody gets up in the morning and does their best in the war, the general might generate a thing, and it's going to be a big thing. The private wakes up, you can only generate a little thing. So everybody's ability to cause an incident is proportional to their span of control.
Right.
You end up with power law distributed incidents. And then there's some things you can do if you truncate the top. You can get some fits for things that you wouldn't normally get. I could go on forever about that. In fact, last year I did. But does that span of control mechanism sound at all like your renormalization?
You know what? So 5 years ago, I would have said, "Oh no, you know that's nothing. This is all to do with that." In the end, what I've realized is there are so many verbal descriptions of models that if you were to then look at that tiny little bit of math that we wrote down, could be framed using that math. So I'm not going to say it isn't. I bet you it could.
I've had that feeling, and it's been driving me crazy because
all I know
to work that out.
All I know is, and I'll say it in an abstract way, if I take pieces, I guess it's pieces of your hierarchical tree, and assume that they become influential with other pieces, and those pieces, you know, then they kind of just coordinate in some way for a moment. That's all we're really saying. So I absolutely agree that there are many different ways of saying, and that's one thing I've learned as I go to retire. Probably that's the only thing I will have. That you can take a tiny bit of simple math that gives the number you want, and you can explain it. You can use words to describe it in many different ways, and it's equally valid. But 5 years ago I wouldn't have said that, but now I absolutely agree.
It's a quick question. We know from some physical phenomena that the identity at the macroscale seems to be stable, even if we have changes in the microscale. Could you comment on the significance of that and whether we can use that as a beacon for finding, or at least hinting at some universality trends, like for example, polymer physics?
Yeah, absolutely right. Alzheimer's, for example, or any neurological disease, you get plaquette. It's believed plaquettes form, kind of aggregates forms exactly like this, due to misfolding proteins. The proteins take up certain configurations and things. But there's something about it, doesn't matter whether I was a smoker or it was something else, or I was smelling doing too much painting. Something formed the misfolding of the proteins that form the aggregates, and now I've got the same symptoms as everyone else who's got that. So I absolutely agree that the symptoms can, on the system level, can even, so it goes back to this. It doesn't matter I think, how you say that microscopics, as long as there's that process that forms the thing within the system. I think the thing within the system, sorry about this untechnical language, but the thing within the system will have some stability in terms of what it does. Yes. But it goes back to this women's movement thing. the devil may be in the details as to why some go, and then we find with these neo-Nazi groups is really interesting. Have I got a minute, just 10 seconds to say this? So when we're looking at the hate groups, and I know I glossed over this, when we're looking at the hate groups, I mean, Europe's a mess. I'm so sorry to say, with my fellow Europeans, but Europe's a mess. Europe is a real mess. These are the connections between the different, but these are neo-Nazi online clusters. And they just, you know. Anyway, the interesting thing is, I can take, there are many cases of two neo-Nazi clusters. I'll take the ones in the UK so nobody gets offended. Well, other than other people from the UK, you know, so, sorry. So anyway, there are neo-Nazi groups, but you look then down in the details. Some of them want as an end game, let's get back to the women's thing, some of them want the Hitler idea of unifying Europe under some thing. But others want to break it apart, you know, not just Brexit, but Brexit to the power of 5, where, you know, you're almost going down to the old feudal system. But they don't realize it. And they're not realizing it yet. So they're both, you know, they're putting up these terrible things and the same imagery, they share the same imagery, they share the same audio files, terrible pictures, terrible text, etc. Nobody has told them, wait a minute, your other axis of what you want as the end game is completely the opposite. So one of the policies would be, you know, don't fight neo-Nazis, and you'll never get anywhere there because they think you're being attacked. No, go along that other axis and say, hey, you want a united Europe. He wants, or he or she wants to break it all apart. Really? What? It's kind of using it the other way around from the women's movement. Yeah.
Thank you very much.
Thank you so much.